We'll start with an overview of microservices and how they are changing the way software is built and deployed, followed by containers and the Kubernetes platform. We will then look at how you can provision and manage storage for Kubernetes workloads using the CSI plugin with an example, and close with a summary of resources available for you to get started. You might have heard the phrase software is eating the world. In other words, software is every organization's business, irrespective of the industry or domain you're operating in. Often, the depth of integration of technology into the business determines the agility with which organizations can bring new products and services to market and dominate their industry. And one of the things that is accelerating this software development is the way it is built and deployed. Software architectures are going through a major change in the way the different parts of an application are interacting with each other. Large monolithic software applications are being broken down into much smaller pieces that are not only functionally independent from a separation of concern standpoint, but can be deployed and scaled independently. This is what the microservices-based architecture is all about. It enables much faster software development. You can rapidly bring new services to production, and these services can be independently scaled. In a minute, we are going to talk about how this is actually done. Microservices are deployed using containers, and they're managed by a robust container orchestration platform like Kubernetes that can manage a large number of containers across a very scalable and distributed infrastructure. Just to contrast with virtual machines, containers don't have the bulky operating system with every instance, but they just have the required dependencies of the application packaged in them. And Docker being the de facto standard to build and run container images. Kubernetes is the core orchestration platform that has now evolved as the de facto choice to deploy containerized applications. You can download the core Kubernetes or the vanilla Kubernetes itself, but there are multiple vendors who are providing Kubernetes distributions with additional features and functionality to make it easy to get started and operate a Kubernetes environment at an enterprise scale. Let's take a quick look at a very important feature of Kubernetes. Kubernetes is a very advanced technology that follows a paradigm of automatic control of the state of a deployed application. It takes the required application deployment manifest as the input and makes sure the desired state of the application and the underlying infrastructure are maintained using something like a feedback control loop, just like in an industrial process control where a range of sensors measure the state of the plant to be controlled and provide feedback for corrective actions to be taken in case if there is any deviation from the desired state. The desired state in case of Kubernetes is specified in the application deployment manifest in a YAML file, which is in the form of key value pairs with very less syntax and annotations. Now let's take an example of this declarative state-based management that we talked about. So we talked about the ability to independently scale a service. Now let's say there is an authentication service, which is typically the service which is used a lot by every other service in the application and therefore needs to be served a lot more than other services. No problem. By just changing one field in the deployment manifest file of the authentication service, any number of replicas can be served. Again, Kubernetes is this orchestration platform which takes the manifest file as the input and spins up the required number of replicas with the right type of storage, with the right service level, etc. that is defined in the manifest. Now let's talk about how containerized applications and Kubernetes are changing how storage is provisioned and managed. With the level of automation that is built into a platform like Kubernetes, you don't expect your development team or the DevOps team to raise a ticket for storage to be provisioned or snapshots be taken or a backup be initiated for their database service. Even a self-service catalog is not practical for the dynamic nature of container deployment. What is required is the ability to initiate infrastructure level operations from within Kubernetes as per the specifications in the manifest. And this is done using storage classes. The application deployment manifest points to a particular persistent volume or a persistent volume claim object of a particular storage class that then maps the persistent volume to a storage device volume. Okay, does this mean you have to start writing storage classes for your PowerMax or Unity or XtremIO? Well, no. We built the integration required to provision storage to a containerized workload using the Container Storage Interface or the CSI standard that the Kubernetes community created. And we built this interface for all of our industry-leading platforms. You can find the CSI plugins for Dell EMC Storage products on GitHub. In fact, we have a web page on delltechnologies.com, which is delltechnologies.com/storage source, that points to these plugins as well as other developer resources. Here you can see that we have the CSI plugins for PowerMax, Unity XT, XtremIO, VxFlex, as well as the Isilon platform. The significance of this is that now with these plugins, the enterprise-grade performance, availability, and economics of these storage platforms are now available for a containerized workload on-premise. Okay, so let us take a quick look at how things work. When it comes to provisioning, we already talked about the application manifest. Here it's a deployment YAML file, and in the spec section is where we specify the storage, which is pointing to a particular persistent volume claim, and on the right we can see the YAML description of the persistent volume claim, which basically points to, in this case, a PowerMax storage class. But this can very well be any one of our storage products that are listed here. Snapshots. In the CSI standard, snapshot is just another storage class. The Kubernetes admin can run the kubectl command to snap a persistent volume, which basically gets cascaded to the storage array, which will snapshot the underlying LUN volume. Since this snapshot is just another persistent volume, it can be used for a test and dev use case where the development version of the service can be tested with the production data by just pointing the snapshot PV in the deployment manifest. Another use case is for an analytics workload or an AI training service which needs access to the latest production data for better model accuracy. Of course, this snapshot can also be used to restore the original volume in case of any data loss. Alright, so here is a summary of all the plugins that are available, and as I mentioned before, you can download and get started with the CSI plugins that are freely available on GitHub for any of our storage products listed here. And the portfolio covers PowerMax, which is the top of the line enterprise storage, scale out NAS platform Isilon, mid-range storage products XtremIO and Unity XT, and software-defined storage solutions VxFlex OS and the VxRail platform. And VxRail, which is all VMware hyperconverged platform, actually uses the cloud-native storage interface for Kubernetes workloads, which is now built into the latest vSphere. Let us talk briefly on the collaboration between the DevOps teams and the infrastructure teams that is required for successfully deploying a workload like Kubernetes. Installing the plugin, of course, is just the beginning. and is usually done by someone who manages the Kubernetes environment. It could be the system admin or a DevOps engineer who is responsible for the deployment part of the DevOps cycle. However, when it comes to ongoing management of resources and data protection, it is still the storage admin who needs to take charge, as he is the expert when it comes to infrastructure. From an operations standpoint, this means you as the storage admin or the infrastructure owner needs to be aware of this new type of workload and the mechanics of storage management in a very dynamic environment like Kubernetes. If you have been in the industry for some time, you may have already seen a wave of change like this with virtualization. And one key aspect of Kubernetes is the level of automation. And this is why we at Dell EMC have also invested significantly to develop integrations with automation platforms like Ansible, which is a great topic for another day. Here are the different integrations for the Dell EMC storage portfolio when it comes to workload support, automation, and integrations with IT operations SaaS platforms. The bottom line is Kubernetes is a new workload that is graduating from the sandbox of a few development teams and is knocking at your data center, and we are building all the integrations required to make you successfully launch this new workload. It's not just the product capabilities, we also have extensive consulting services that can help you adopt a DevOps-centric, agile IT operations, which not only means new workloads like Kubernetes, but also a new way of infrastructure management through something called a declarative configuration management, which is similar to the application deployment that we have seen that can happen in a declarative style in a YAML file, where you specify the end state of the infrastructure or the application, and the underlying automation platform like a Kubernetes or Ansible would automatically drive things to reach that state. Before we conclude this webinar, here are the different resources for you to learn and get started with the different integrations of the Dell EMC storage portfolio. Again, the hyperlink here is delltechnologies.com/storage source. Hope you found this webinar useful. Please feel free to email us if you have